Here is an example of tool compensation offset. We'll be using G41, which is offset to the left. G42 would be offset to the right. The way I normally envision it is if you were driving in a car and you're going in that direction, left would be offset 41, right would be G42. Now we'll begin with the percent sign, which is a flag to tell the machine to start the program or begin communication. Next we'll have the program number preceded by the letter 0, or you can use the semicolon. Here we'll have comments. You can see they're in parentheses. They won't be executed by the command control. And it's telling us that tool 1 is a 3/8 inch end mill, tool 4 is a 1/2 inch end mill, and the comments continue. Tool 6 is a 1/4 inch diameter drill. What we'll be doing is cutting the interior in a square 4x4 in the middle of this 5x5 inch 1 inch deep piece of stock. Here we can see that we've commented that the registry entry for number 4 will be a 1/4 inch. The registry entries for tools or offsets 6, 7, 11, and 14 will be 50/1000ths of an inch. Here we have the prerequisite codes. G90, which is absolute programming as opposed to incremental. G80, which will mean to clean out any existing CAN cycles. G40, which is important to clean out any existing compensation registry entries. And G49, which is to clear out any tool height offsets. G17 will denote the X and Y plane. Here we have the G90 repeated. It won't hurt anything. And we're going to go to G54, which is a 0, which I've set to where the tool is presently. That will be the 0, and this is a command which is telling us to go to X0 and Y0. Now we're making a tool change to tool number 1. And now we're starting the spindle clockwise at 3056 RPM. Okay, we have the rapid command. We're going to G54, and we're going to go to 1 1/4 inches X and Y 1 1/4 inch. And now we're adding a tool length compensation offset, which will be designated in registry number 11, denoted by the H, and we're going to rapid down to 100/1000ths above the piece. And here we can actuate the coolant. Coolant 2 is now on. And now we're going to traverse. We've switched the mode from G00 to G1. And since there are two designated geometry entries here, X 2.5, Z -125 at a feed rate of 3 inches, the tool will traverse on an angle. We're going to do that because it's more prudent to feed the end mill tool into the material at an angle, particularly if it's harder material such as stainless or 4140, to prevent damaging the tool or possibly even breaking it. So we'll execute that command, and we've executed it so that we've moved 2.5 inches in the X direction, and we've moved down in the Z direction 1/8 of an inch, 125. We'll complete our entry move by coming back at X 1.25 or 1.25 inches down to a depth Z of -1/4 inch at 5 inches per minute. The F designates the feed. Now we'll traverse to 3 3/4 inches in the X direction. Now we'll traverse to Y, 3 3/4 up to the Y direction. And now we'll traverse to X 1.25 in the X direction to that coordinate. And now we'll come down to the Y 1.25 in that direction. And you can see that we've changed the mode from G1 traverse to rapid, and we're clearing out the length offsets, and we're also homing the machine to make a tool change, and that happens to be on this particular instance Z plus 3 inches. Now we're going to turn off the coolant, which is the M09 command, and we will stop the spindle, which is in the M5 command. And that's the end of this particular operation, which we've denoted by the M1 command. We've now entered more comments, which is to change to a 1/2-inch end mill. This time it'll be with comp. The previous tool was on the tool center, which was a 3/8-inch end mill, which cut a 1/2 inch, a 1/4 of an inch deep. This recess, which is 4 by 4 inches square, and now execute the tool change, which is tool number 4, which is a 1/2-inch end mill, and that will be going down a full 1/2 inch. Start the spindle at 1528 RPM, and we'll rapid to the G54, which I told you is the 0, which is in the lower left corner, and we'll be traversing to these coordinates, 2.25 X, Y 2.25. And now we're going to pick up the height offset and bring it down to 100 thousandths above the stock with the registry of H14, and we'll also turn on the coolant. And now we'll be switching modes from rapid to feed, traverse, to the X 1.25, Y 1.25, and the Z, all 3 coordinates, 1/2 inch negative into the material at a rate of 3 inches per minute. Okay, now here's where we will enter the compensation left, which is the G41, and the coordinates that we've entered are X 1/2 inch, Y 1 inch. The D is the diameter, which we'd entered into the registry previously, which is going to be the radius of the tool, which is a 1/4 of an inch, since it is a 1/2 inch end mill, with a feed of 6 inches. Now, it's important to remember that compensation always lags behind, because there's a read ahead buffer in the control, because the tool has to know where it's going to follow the geometry to the left-hand side ahead of time. It has to know where it's starting, and has to know where it's going to end up, depending on the size of the tool. And we've moved to that coordinate, and we're going to be moving to the, remember we're looking ahead, the X 4 inches. Now to the X 1 inch, or Y 4 inches, up to the top, to the X 1 inch. Remember, we're looking ahead. And now down to the Y 1 inch with the 1/2 inch end mill. Now you can see we've entered a G40, which means to cancel all that compensation for this particular tool. And we've entered the coordinates of 1.25 inch and a 1/4 for X, and Y 1.25. And those are the positions that's the position that the tool will stay at when the compensation is canceled. And we've executed the rapid, canceling the length compensation and going to the tool change position. And now we will stop the spindle with an M5 and end this particular operation with an M1. The M1 sometimes is good to clear chips off or do inspection on the piece, so sometimes it's a good idea to put it in the program.